Hello everyone, welcome to this video where I'll walk you through the entire process of a machine learning project from start to finish. In this video, we'll cover everything from problem formulation and data collection to model training, evaluation, and deployment. We'll also demonstrate how changes to the data impact model performance and how we deployed our machine learning model as an API. For our project, we chose to predict the likeliness of a user to reorder a product in a grocery store. The goal is to build a model that can predict if a product will be reordered based on input features like the user's history of purchases and the date and time of purchase. Next, data collection is crucial. So we use the dataset from Kaggle, and this dataset contains the purchase of history of a user, information about their orders, reorders, and what products have been bought. So this is the dataset that we used, and the rows of the data such as user ID, product ID, days since prior order, reordered, and other features. We selected this dataset because it has a good balance for data for training and a predictive model. Before we dive into creating the model, we needed to pre-process and clean the data that we used from Kaggle. In our case, we started by first checking for duplicate values in the dataset. If there are duplicate values, they were dropped from the dataset. Next, missing values from the days since prior order were filled with the mean value of the column, as seen in the code here. Then all columns were renamed to lowercase for consistency. Furthermore, we also applied the following transformations. Categorical variables such as department and product name were converted into binary columns using one-hot encoding. To capture how often each product was purchased, we grouped the data by product ID and counted the number of entries in each group. The result was merged back into the dataset as a new column, purchase frequency, providing insight into the product popularity. To analyze purchasing patterns, we calculated the average days since prior order for each product by grouping the data by product ID. This average was added as the average days between orders column, helping to identify products purchased regularly. Finally, a binary flag, high priority product, was created to highlight specific products deemed important. For instance, products in the produce department were flagged with other products defaulting to 0. And after we processed that, we visualize the data to understand the relationships between features and the target variable. And these are a few of examples of our data visualizations. For example, let's take a look at how the feature reorder frequency correlates with the hour of the day. In this histogram, in this bar graph, the highest frequencies happened during 10 a.m. to 3 p.m. window. The next shows the correlation between the frequency of reorders and the days prior to reorder. It shows that the highest frequency of reorders happens at 8 days and 30 days.
So after data pre-processing, we now have to upload the dataset in Vertex AI. To do that, first you have to create a dataset and then select the data type and objective. In our case, the data type is going to be tabular, and our objective will be regression or classification, more specifically, binary classification. Okay, now that we have created the dataset, we now have to select the data source. So in this case, since our dataset was so large, we had to use cloud storage. So we selected the CSV file from cloud storage, and to upload it or to transfer it from our Python notebook to the cloud storage, we had to use Google Colab authentication and copy the pre-processed data to the Google Cloud bucket. So after uploading, we now can check the details of our dataset. So for our case, we created it on November 2, 2024, and we have 2 million rows and 161 columns. Now that we have created a dataset in Vertex AI, we can now train a model based on that dataset. So first, we have to name our training model, determine the cloud storage location, which is the same bucket that we've used earlier. Then we have to provide more details about the dataset. Our objective will be in this classification, as we mentioned earlier. And our target column is the reordered, which is a binary variable column, either 0 or 1. And then that's the model name. And then we have to transform all of our columns into their respective types. So since we have already one-hot encoded each of the categorical data, all of our columns is now numeric. So we have to transform all of the columns to numeric. Okay. Then finally, we have to set the maximum number of node Rs that we will use for training. In our case, we just use one node R, which is the minimum possible. Okay. And you can see on the bottom part here that we have already trained our model, and it took around 3 hours and 29 minutes. And was last updated in November 3, 2024. Okay. So now that we have created our model, we now have to evaluate the accuracy of our model. And in our case, our F1 score ended up being 0.781. And here is our confusion matrix. So we can see that our model was actually more likely to predict that our customer will reorder rather than not. So it's a bit more optimistic. So in the case that the customer actually did reorder, the model was able to predict 96% of the time that the customer will actually reorder. However, in the case that the customer did not reorder, our model was only able to predict 28% of the time that the customer will not reorder. So our model is a bit more optimistic that a customer will reorder. So now that we have evaluated the accuracy, let's now determine which of the features of the model that are most important. So if we want to improve our model, here are the features that we have to look at. So in our case, our top 3 features are days since prior order, purchase frequency, and average days between orders. So the top 2 and top 3 are actually columns that we have artificially created to provide more context about the data. Right? After training and evaluating our model, we can now deploy a machine learning endpoint. So now we can access our model outside of the Google Cloud Console. So to create an API, we first create an endpoint name, and then in the model, we have to set the maximum number of compute nodes to 1, and the machine type to be E2 standard, 2 vCPUs, and 8 gigabytes of memory. As for model monitoring, we decided to opt out since it will cost more. And after that, we have successfully deployed our machine learning endpoint, as you can see here. It's now active. Right. So to demonstrate how we are going to use our API, we have created a short front end that will submit all the details and get the results of our model. So first you have to input the user ID. So this is how we calculate all the data about the user's purchasing habits. So our front end actually can autocomplete the user ID. So imagine you're at a grocery store and then a user checks out, and we can match the user ID on our database and get its data. Then we have to input the order date. So when did the user buy the product? Okay. And then we have to type which product did the user buy. So as you can see here, we have autocomplete. So these are the available products that we have. And in this case, let's say the user purchased some eggs. Okay. So user ID 49125 ordered at December 4 at 9 p.m. and the product is eggs. So these are the data that are submitted to the model. Okay. So we submit it. And then we have our prediction. So our model predicted that the customer will reorder, and here's the probability. So there's a 74% chance that our customer will actually reorder, and there's a 25% chance that our customer will not. Just a quick run through on our code on how we converted the inputs of the form, which is the user ID, the product ID, and the date and time. Here is the code. So here is the JavaScript that handles the form submission. So it gets the user ID, the product ID, date and time, then converts the date time to the day of the week and the hour of the day. Okay? And then it calls upon an API request from our Flask backend. So this is the link that I've set for my Flask backend, which is defined here, API predict. So the HTML file, the JavaScript calls this function basically, and it will return some response, which is the response of the model. So after bringing in the data from the form, we now extract user ID, order of the day of the week, and product ID. And after that, we have to pre-process the input of the form. So here it is. First, you have to filter out the data from the pandas data frame, which of these data belongs to the user. And then, you have to calculate the days since prior order of the user. So just get the days since prior order and get the minimum. Okay? And then, for purchase frequency, we have pre-calculated all of the purchase frequencies of all the products, and we just get the product ID. And we can see that here. So data, so group by product, and then the size of this, and we convert that into this purchase frequency. Okay? And same with average days within orders. We pre-calculated the average time between purchases for all products, and we just get the product ID. Okay. And then for high priority product, we just set that to true if the department is a produce, otherwise it's false. And then we just print it for debugging. I've actually printed that here. Days since prior order, we have 9, so the user ordered 9 days ago. Purchase frequency is around 28,000. So out of the 2 million orders, 28,000 of those are eggs. And the average days within orders, so users generally order eggs around every 12 days or so. And since eggs is a produce, it's a high priority product. Okay, since we now have to generate the instance, which will be sent to our model. Order of the day is the order of the day, order of the week. We already calculated this earlier. And day since our order. So this is basically creating just the JSON file that will be sent. Then we have one hot encoding. So we set the product and the departments that are true. So we set this one, we set it to true. Okay. And all the other departments and products, we set it to false. Okay. Then we return the instance. So we go back to predict. So here is the instance. And then we get the access token, which is from our service account credentials. So we just get that here. It's the JSON file. Okay. Headers. So this is the access token. And then we sent the post API request. And then we get a response and return that to JSON and we return that. We return that in our code and in our JavaScript. We fetch it. And then here is the response. And then now we convert the results, add that to the div with ID result. And here are the paragraphs that are generated by our model. So the reorder text, is it likely to reorder or not? So we just check it if it's greater than 0.5, it's likely to reorder. Otherwise, it's unlikely to reorder. So that's it. So that's how we first get the input, turn it from inputs of the form to inputs of our model, and then after getting the outputs of the model, process that and then display that in our front end.
Now that you've seen how the system works from a technical and operational perspective, let's discuss its strategic impact on the business. This system isn't just about making predictions, it's about enabling smarter, data driven decisions across the organization. Once the predictions are generated, they can be directly applied to improve various aspects of the business. For example, marketing teams can use these insights to create personalized campaigns, such as sending targeted reminders or product recommendations to customers who are likely to reorder. Inventory managers can rely on the predictions to prioritize restocking items with a high likelihood of being reordered, reducing the risk of stockouts and improving overall efficiency. Additionally, customer retention strategies can be enhanced by focusing on users who may need a nudge to make their next purchase, whether through loyalty programs, tailored discounts, or special offers. By leveraging these predictions, the system helps businesses make smarter, more precise decisions that ultimately drive growth and customer satisfaction. This isn't a one and done system. The model continuously learns and improves as more data is fed into it. Businesses can monitor key metrics such as reorder rates or changes in purchasing patterns and adapt their strategies accordingly. This system empowers businesses by turning raw data into actionable insights. Whether it's optimizing inventory, driving repeat purchases, or tailoring marketing campaigns, the ultimate goal is to make every decision more precise and effective.
In summary, the benefits of using this machine learning process are substantial. By automating the prediction of user ordering behavior in a supermarket, we enhance accuracy, efficiency, and scalability in managing inventory and personalizing customer experiences. Deploying the model as an API makes it easily accessible, enabling real time predictions that support data driven decisions in production environments. Whether you're optimizing stock levels, improving product recommendations, or streamlining operations, this machine learning solution empowers supermarkets to address complex challenge and deliver actionable insights that drive better outcomes.
Thank you for watching this video. We hope that you now have a clear understanding of how to approach a machine learning project from problem formulation to deployment. If you have any questions, feel free to leave them in the comments below.
Also, don't forget to like, share, subscribe, and click that notification button for more machine learning content. Thank you.